Hello and welcome to Future Cookie. Today we are sitting with a story that will change the way you think about what medicine can actually do. What if the disease you were born with could simply be switched off? Not managed, not slowed down. Switched off? That question is no longer hypothetical. For millions living with sickle cell disease, the answer just arrived. Imagine being 12 years old. You spend more days in a hospital bed than in a classroom. Your blood cells are shaped like broken crescents instead of smooth circles. They jam into your vessels and cut off blood flow. The pain arrives in waves so severe that doctors call them crises. That is not a metaphor. That is Tuesday for someone with sickle cell disease. For generations, families passed this condition down like an unwanted inheritance. You managed it, you prayed through it, you endured it. There was no cure until now. The FDA has approved Casgevy. It is the world's first gene-edited therapy for sickle cell disease. It was developed using CRISPR-Cas9 technology. Those are molecular scissors. They find a precise location inside your DNA and make an edit. Not a patch, not a workaround, an actual edit to the source code of the disease. Here is how it works in plain language. Scientists take stem cells from the patient's own bone marrow. They use CRISPR to reactivate a gene called BCL11A. That gene normally stays dormant after birth. When it turns back on, it triggers fetal hemoglobin production. Fetal hemoglobin is what healthy babies carry before switching to adult hemoglobin. In people with sickle cell, fetal hemoglobin works. It does not sickle. It carries oxygen the way blood is supposed to. In clinical trials, nearly all patients went 12 months or more without a severe pain crisis. People who had planned their entire lives around pain suddenly had none. That is not a statistic. That is a life returned. If these stories are sparking something in you, I want to invite you to subscribe. Every week we bring you the science that is quietly rewriting what is possible for human beings. Hit subscribe and let us keep exploring this together. Now here is where the stakes get even bigger. Sickle cell disease affects roughly 100,000 Americans. Millions more live with it around the world. The highest burden falls on people of African, Middle Eastern, and South Asian descent. This approval is not just a medical milestone. It is a statement about who science decides to show up for. There are real limitations worth naming honestly. The therapy currently costs around $2 million per patient. The treatment is intensive. Patients go through chemotherapy first to clear the bone marrow. Then the edited cells are introduced. Access will be the next great challenge. The science has cleared its highest hurdle. The system now has to decide whether it will follow. And yet, what this moment signals cannot be overstated. For decades, CRISPR was a laboratory idea, a fascinating, controversial, theoretical tool. This approval proves it can move from hypothesis to human cure. Sickle cell was chosen partly because it is a single gene disorder. But researchers are already asking what comes next. Thalassemia, certain cancers, rare genetic conditions affecting children before they ever take their first step. We are not in the era of gene therapy as science fiction anymore. We are in the era of gene therapy as medicine. That shift from fiction to prescription pad is the signal. Future Cookie is here to help you read. 80 years from now, people will look back at this moment. They will see it the way we see the first successful organ transplant. They will say, that is when everything changed. You are living in that moment right now. You just watched science do something that was impossible 20 years ago. The question worth sitting with today is this. If one edit to your DNA can end a lifetime of suffering, what else are we one discovery away from changing forever? I would love to know what you think. Drop a comment below and tell me what condition or disease you most want to see this technology tackle next. Or ask me anything about CRISPR, gene editing, or where this technology is heading. These conversations are where the real thinking happens, and I read every one. Thank you for joining us today. This is Future Cookie.